So the purpose of today is to give an overview of Kirchoff's loop rule. And by definition, it's the sum of all voltages around a loop are equal to zero. Those are some words. If I show you here on a couple examples, it should make a lot more sense. This first example here, we should be familiar with this. We have a multimeter showing voltage. What we see is as we go across the battery, and here we're doing electron flow for current, as we go across the battery, we see a voltage increase of 9. So this is plus 9. So I could show you if we went just like right here, the voltage there is 0. If we went over here, voltage is 0. But if you go across the battery, the voltage goes up by 9. What the loop rule says is as the circuit is completed, as those electrons follow the path through to the other end, all 9 of those go away. So it starts out as 9 here and it goes to 0 here. And we can see that as it goes across this light, if you look, and again, you have to go, the red shows them going in, the black shows them going out. If we put red going in and black going out, we can see that 9 volts is being subtracted away or being used up. So that's what takes it back to 0. And in fact, we can move on. And if we have a circuit here, more lights. Once again, we have a battery providing 9 volts. And we notice that the black is always with the electrons coming out. If we were to go over here and measure the voltage across this light, now we only have -3. That's because the loop rule says it's whatever starts here has to all get subtracted away. And if the resistors or the lights are equal to each other, it's equally divided by 3. So we get 3 across each of them. So see, it says -3, -3. If we go over here, it's minus another 3. Now, if we were to go across all 3 of those, of course, it'd be -9, or just across 2 of them, it would be -6. So then if things get a little bit more wonky, if once again we have a 9-volt battery, and this is kind of weird, but in this case, the loop rule still works, and it's important to realize what the loop is. It's the path the electrons would follow, and so they pick one of these two. These lights are in parallel, so across either one of these lights, you have 9 volts being subtracted. And you should notice the voltage drop is actually basically the energy being consumed, which would be represented by the brightness. So remember how these were 3 volts, not as bright, 9 volts, really bright. And so this voltage is very much connected to the energy that's being consumed from our energy equation, our power equation, but we're not going to talk about that right now. And then finally, it's worth noting here we have again a circuit with 9 volts being added. It's worth noting that resistors and lights are effectively, this all works the same. So across this first resistor, we have a voltage drop of -0.82. And then if we go across any one of these lights, they're all the same. So their voltage -2.73, -2.73. If we were to do all 3 of these, it's going to be 8.18, because that 8.18 plus that one is going to equal 9. And we can see that if we go all the way across all of these, you have 9 being subtracted away. And that is the loop rule summarized for you. Thank you and best wishes.